I'm Anil Kumar. In this particular video, I'm going to take up a very important concept, and that is to find the chord length. Three different diagrams are given, and the question for you is determine the length of chord AB in each circle to the nearest hundredth. This is a very important exercise, and it is also going to lead you to application of sine law and ambiguous cases. Now AB is this length of the chord in each of this question. Now let us discuss the approach. Now in the first case, if you look at the triangle CBD, you are given angle and opposite side, right, another side, so you can apply sine law. So these are all application of sine law. Another important thing which you notice here is that whenever we talk about the radius, then if you join C with A, we get two sides, and the other side is also 18, right? It forms an isosceles triangle. Okay. Our approach is going to be apply sine law, and in the first case, we can actually find angle B, right? So we'll find first angle B by applying sine law, since we know side opposite to angle B. Once you find angle B, then we can find angle C, since angle B is also equal to angle A, and then we will know angle C. After knowing angle C, we can again apply the sine law and find the side AB. So that is the approach. In the second case, it is very similar to what you have here. The only thing is, you are given equation of circle, which is x squared plus y squared equals to 225, which is 225 square root is 15, right? So what you can do is, you can do square root of 225, it is 15. So you could write this as 15 square, and that really means that joining C to a point on the circle gives you radius of 15, right? So these two are 15. Now this question becomes exactly similar to the previous one. Perfect. So you could always solve this question. Now in the third case, there is minor difference. We are given length dB, right? So what we are given here is the length dB, and what we need to find is the length AB. So, well, the strategy is similar. Join this point. Now, once you know this length, you can actually find the bigger angle this time. You can find the bigger angle, correct? Well, here in this case, you could find the smaller angle also. The radius given to us is square root of 169, which is 13 square. So the sides given to us are 13 each. Okay, so with that, you can actually solve this particular question also. So I hope it is not very difficult. Let us see how to solve them one by one. You can always pause the video, answer these questions, and then look into my suggestions. So A, the first one here, what we will do here, as discussed before, we'll find angle B. Since we are given side opposite to angle B, right? So application of sine law, we say sine of angle B over side opposite is 35 is equal to sine of 5 degrees over 18. So sine B is equal to 35 times sine of 5 degrees over 18, right? So let's calculate this out. So we have 35 times sine 5 divided by 18 equals to 0.1694 is sine B. And therefore angle B is equals to sine inverse of this value. So we do shift sine inverse of our answer equals to 9.75. So we get 9.756. Now in this case we have to round to 100, so we'll round it to 9.76 degrees, correct? So we know what angle B is. It is 9.76 degrees. If I join C with A, this angle is also same. Perfect. Now because of that, we can now find what is angle ACB. So ACB is 180 degrees minus twice 9.76, correct? Since this is isosceles triangle. So it is 180 minus 2 times 9.76, which is equal to, in decimals, 160.48 degrees. Since we know angle C now, we can again apply the sine law and find the segment AB. So now we can say that segment AB over sine of 160.48 degrees should be equal to 18 is the length of the radius divided by sine of 9.76. So from here, AB, the chord length, will be 18 times sine of 160.48 degrees divided by sine of 9.76 degrees, correct? So we get 18 times sine of 160.48 divided by sine of 9.76 equals to 35.478, right? Rounding to 2 decimal places, which is 100th, we get 35.48 and the units are meters. So our answer is that chord length AB is equals to 35.48 meters. Now here is second example to find the chord length. Let's say part B. We are given the equation of the circle as x square plus y square equals to 225. So we have x square plus y square equals to 225. Now square root of 225 is 15. So you could write this as 15 square. So as you remember, the radius is 15 in this particular case. So we are given radius. I could join C with A, so that becomes the radius also. Now let us see how to solve this question. Well, the approach is very similar to what we adopted last time in part A. Now we can find angle B, that is the first step. So sine law is going to be applied again. So we can say sine of angle B over the length opposite to angle B is 20 meters here. We are considering the big triangle, right? In the triangle CBD. So we are talking about triangle CBD. So sine B over 20 is equal to 15 over, sine 25 I should write on the top since I wrote angle earlier, sine 25 over 15. And so from here, sine B will be equals to 20 over 15 times sine 25. So let's calculate this answer. It is 20 times sine 25, and then we'll divide this by 15. It is equals to 0.563, let's say 5. And angle B, therefore, is sine inverse of this, which is 0.5635. So if I do inverse of the result, we get 34.29 7 degrees. We need to round our answers to 100th, so we can say that angle B is equals to 34.30 degrees, correct? So we know this angle as 34.30. This angle is also same as the angle on the other side. Now that helps us to find the angle C, right? So we know angle ACB will be equals to 180 degrees minus twice 34 point, this is 34.30. Right, so let's calculate this. 180 minus 2 times 34.30 is equal to 1111.4 degrees. So that is the angle at the vertex of this triangle. So this angle we just calculated as 111.4 degrees, correct? We can again apply the sine law and find what AB is. So AB over sine of the angle 111.4 equals to sine of 34.30 divided by 15. So AB is now equal to, we applied it wrong. So I should have written 15 over sine of 34.30, correct? So AB is 15 times sine of 111.4 divided by sine of 34.30. So whenever you take this ratio, you have to be careful. Either you keep the lengths up or you keep the sines of angles in the numerator, right? 15 times sine of 111.4 divided by sine of 34.30. That gives you 24.78. So the answer here is that the length of the chord AB is equals to 24.78 meters, correct? So I hope the concept is clear. You have to apply sine law twice to get your answer. Now let's go to part C. We are almost at the end. We'll need to find the chord length AB in the given situation. Circle is given with the equation of x square plus y square equals to 169. So let me rewrite. X square plus y square equals to 169, which is 13 square, right? So that simply means that the radius given to us is 13. So if I connect C with A, these are the two radius and the lengths are 13, units will be meters. Now in this particular case, we are actually given D to B distance, right? So that is the distance 33 meters, and we have to find what is the chord length. That's the question for you. You can pause the video, answer, and then look into my suggestions. So let's begin by solving the triangle BCD. We can apply sine law here, just as we did earlier, right? Now we need to find because we know the length, so we can find this big angle, which is angle BCD. So we can write sine of angle BCD over 33 is equal to sine of angle 19 over 13. So that means sine of angle BCD is equals to 33 times sine of 19 degrees divided by 13. So we get 33 times sine of 19 divided by 13. So that gives you 0.82644. Then angle BCD will be sine inverse of this angle, 0.82644. Now here is a word of caution. This is where the students might do a mistake, and probably that's the reason why Shruti is asking for my help. Okay, now this angle is an obtuse angle, so we can see that angle BCD is an obtuse angle. Since it is an obtuse angle, we have to look for a solution which is in quadrant 2, right? Sine, as you know the rule, all are positive here. Sine is positive in quadrant 2, tan in 3, and cosine in 4. So as you know, we are looking for a solution whose, we can find the acute angle here, less alpha, but truly the answer is the angle which is the obtuse angle, correct? So whatever this angle is, this is actually not BCD. We have to, because we are looking for an angle in quadrant 2, we are looking for obtuse angle. You can get an idea, right? So let's do this. So what you get here is shift sine inverse of 0.82644, and what you get here as 55.73. So we get this is 55.73. Now strictly speaking, this is the acute angle alpha. So note, this is not BCD. This is acute angle. Let me write down acute angle in quadrant 1, which is 55.73. The actual angle should be, so angle BCD is actually 180 degrees minus 55.73. You get an idea. So the actual angle is 180 minus 55.73. So that is why this question is kind of typical. So we have 124.27 degrees as the angle BCD. So here I should not have written BCD, but we'll find related acute angle. Alpha. Do you understand? So, and then we'll find the angle BCD by the concept which I was just talking about. I hope this point is very clear. Knowing this angle BCD is 124.27, we can find angle B. So now we can find angle ABC as equal to 180 degrees minus 19 degrees minus this big angle 124.27 degrees, correct? So let's do this. So we'll do 180 minus 19 minus 124.27. That gives us in decimals 36.73. So 36.73 is the angle B for us, correct? Now here also these two are equal, so we can find what is the angle ACB. So ACB will be 180 degrees minus twice 36.73, correct? So let's do that. So 180 minus twice 36.73, and this is equal to, in decimals, 106.54 degrees. You get it. So this angle here is 106.54, and now we can apply sine law in the triangle. So now we'll apply sine law in triangle ABC. Do you see that? So once you do that, what you get here is that AB over sine of this angle 106. So we're talking about this angle now, which is 106. So sine of angle 106.54 should be equal to the length 13 over sine of angle B, which is 36.73, right? So this is 36.73. So AB is equal to, cross multiply, 13 times sine of 106.54 divided by sine of 36.73. So we get 13 times sine of 106.54 divided by sine of 36.73, and that is equal to 20.838. So we can approximate our answer to AB equals to two decimal places, 20.84, and the units are meters. Correct? So that is how it can be solved. So I hope with this example you know the variety of questions which could be asked directly to find the chord length. We'll take up some application questions based on this, and I hope with that you'll be ready for your test on this topic. Feel free to write your comments and suggestions. It'll be great if you like and subscribe my videos. Thank you and all the best.